This is a little overview into solving proportions and showing a couple of different strategies on how to do it. So once again, a proportion is an equation stating that two ratios or fractions are equal. And if you're setting them up, once again, you want to make sure that it's kind of this part to whole, part to whole. So if there are units, such as miles and hours, make sure that it's like miles to hours, so that the units match up. Otherwise, the proportion is not set up properly. Or they might not have units, so you can see like 3/4 is equal to 30/40. So once again, a proportion, two ratios or fractions equal to each other. So we're going to look at three different strategies. The first one is a giant one. So if you've got an unknown and you can see that there's a clear relationship between, either the numerator and the numerator or the denominator from the other one, then you can multiply by a giant one. So I can see 2 times what gives me 14. So I can see this would be a giant one of 7/7. Multiplying it out, I get 35/14. And so basically this x over 14, the x is equal to 35. Okay, so that's one method. Once again, it only works if you can see a relationship that the denominator or the numerator can be multiplied by something to get to that other piece. So it doesn't always work, but if you can do it, nice strategy. The other method is undoing division. And this is kind of, we're looking and we're trying to get the x by itself. So I can always ask, is the x by itself? No, it's not. What's happening with it? It's divide by 14. So I want to undo the divide by 14, and I'm going to do the inverse operation. So I'm going to multiply by 14, and I'm going to kind of keep it balanced by doing multiply by 14 to both sides. Some people like to do the little over one just to make it a little easier. And here I can see 14 over 14. Oopsie, I don't think you can see that. So 14 over 14, that is just a giant 1. So there I can just cancel that out. So I have 1x, or x, and on the other side, I could multiply it out first, but I can also see that there's some canceling here. So divide by 2, 1, divide by 2, 7. 5 times 7 equals 35, and the denominator is 1 times 1, so this is over 1. Or you can just say x equals 35. Once again, it's the same problem as above, so you can see I'm getting the same answer. So that's that is helpful. Okay, and then the last method, there's a couple of different ways to do it. I'm going to actually show a method that's a little bit longer, but doesn't hide any of the mathematics. So some people use cross multiplying. I don't think that's so helpful because then people often misapply it. So I want to get the x by itself. So what I'm going to do is I'm going to multiply just like I did above. So just like I did above here, I'm going to multiply both sides by 14. And then also multiplying both sides. So I'm going to get rid of, like, it's like maybe you're one of those people that's just like, I cannot deal with fractions, too difficult. So if you multiply both sides by both denominators, so I'm multiplying both sides by 14 and both sides by 2, what happens is that you can start to cancel stuff out. So 14 cancels 14, 2 cancels 2. So I end up with 2x equals, I don't know my math here, 50, 70. And then to get x by itself, I'm going to divide by 2, divide by 2. Here's a giant 1. So x equals 35. So there are a couple extra steps in there, but it really shows you the y. So some people do this process called cross product, where they multiply this out and they get 2x equals 70. But this is actually showing the reason why this happens, is you're basically multiplying both sides by both denominators, and then you're simplifying. So this is a better method mathematically, because this one people will start misapplying. So if you do this method, it will help you eventually get to the shortcut. Okay, so good luck. So once again, you have the three methods. The giant one only works if the denominator is kind of a multiple of the other. undoing division, so basically instead of divide by 14, multiply by 14, or this third method, if they're just multiply each side by both denominators and then solve it from there. Okay, good luck with that. Once again, practice, practice.